Hey, peeps, and welcome back to part 5 of the 3 Degree of Freedom motion simulator platform top frame build. It's time for us to move to the front of our top frame and set up our tie rod to motor to top frame connections. I'm going to start with some bracing. So you guys will need to get some 25 by 25 by 2mm wall or 3mm wall. And you'll need to cut 2 lengths at 80mm in length. Okay, and then on each length, you'll clean up one end, put a little bevel on both. The other end, just clean up the insides. This end where we've cleaned up and beveled, we're going to be welding. Once you've got those 2 80mm lengths of 25 by 25 cut, bring them over to your top frame to the very front. Okay, get a ruler, measure from the very right hand edge. Okay, measure in 140mm, make a mark, put your square on top of your top frame and draw a line. Make sure you've marked the center of your 25 by 25, 12.5. Forgive this, my Sharpie died when I was doing this, so it's a super thick line, but you need the center of your 25 by 25 lined up because you're going to line it up with that 140mm mark. You're going to do exactly the same on the far left-hand side of your top frame. Measure in 140, mark it on your 30 by 30, put your square on, draw a line, and then the center of your 25 by 25, this is where you're going to weld these on. Now, you need to weld this 25 by 25 right on the face of this, okay? Remember, this is 30 by 30, this is 25 by 25, so your 25 by 25 is going to be sitting inboard on your 30 by 30 a little bit, but it has to be flat on the face here. So once you've welded around, okay, make sure you get your grinder and just clean these front areas up here so they're nice and flat, because our timber bracket's going to be sitting on this and it needs to sit nice and flush. You guys will cut a length of your 140 by 20mm hardwood decking at 560mm in length. Once you've cut it, do what we did with our other motor mount timber brackets. Get your sanding pad on your angle grinder and clean up right around. Round off the edges, round off the corners, both ends. Then we'll call this the top edge. From our top edge of this, we're going to measure down 15mm and make a mark. 15mm, make a mark. 15mm, make a mark. Put your ruler on or your level, whatever's long, and draw a line along those marks to get a 15mm line from the top edge of that piece of timber. Now on the other side, ignore the 2 lines here. We only have to worry about this line here where these holes have been drilled. And that line is 30mm from our top edge. So we're going to do the same as we did on the other side, but this time we're going to measure 30mm, make a mark, 30mm, make a mark, 30mm, make a mark, put your ruler on and draw a line. This is where our holes will go, that our tech screws will go through and into our frame. Okay, now from this edge, you'll measure in 60mm and do a little cross. From that little cross, you'll measure 80mm and do another little cross. From that one, you'll measure another 80mm and do a little cross. All right, so just cross those lines at 60mm and then 80mm from that one, 80mm from that one. Then at the other end, it's the same as this end. You'll measure in 60mm, make a mark. From that mark, you'll measure 80mm, make a mark. From that mark, you'll measure another 80mm, make a mark. Okay? Then you will drill 1, 2, 3, 4, 5, 6 6mm holes along that line. I would recommend that you just do a little pilot hole with like a 3mm drill bit first so they don't walk. Okay guys, from both ends of our timber, we're going to measure in 140mm, make a mark, put a square on and draw a line. Same with the other end. 140mm in, make a mark, put your square on, draw a line. Then from our 30mm line here, from the top where we've drilled our holes for our tech screws, you'll measure down 30 millimeters, make a mark, then measure down 80 millimeters, make a mark. Same with this one. From our 30 millimeter line here, measure down 30 millimeters, make a mark, measure down 80 millimeters, make a mark, and drill those two marks at 30 and 80 with your 6 millimeter drill bit. Okay guys, you're going to bring your 560 millimeter 140 by 20 hardwood that you've cut over to your top frame front end. All right, now that 15 millimeter line that we measured on one side of our 560, you're going to line that up with the top of your top frame right along, right? This still isn't quite right here, so I'll set this up in a second. Just, you'll need to clamp it with your F clamps, or if you've got your vice clamps, very good. Clamp it, and then just with it, so you can clamp it so the line's a little bit high, then get your hammer and just tap it until your line comes down level. This end's not too bad. This end here just needs to be tapped down until that's level. Both sides are lined up on the ends here the same, okay? With mine, they're just inboard the frame just a tad on both sides. So get them lined up as well. So you've got to get them lined up on the edges, and then you've got to get that 15 millimeter line lined up with the top of your top frame. So these are all of our points now where we'll be able to tech screw. Okay, so the top line goes into our top frame, and then these guys where we measured in 140 and marked these at 30 and 80, they'll go into our little 25 by 25 bracing pieces that we've welded on. So you'll tech screw all of those with your 35 millimeter 12G techs and your impact drive with your 8 millimeter or 5/16 hex socket. Let me show you how we set up our top frame front bracketing that connects to our motors. Bottom section of this needs to be made. The section where your bolt will come through. So what I've done here is I didn't have the correct bolt length. So what I've ended up doing is I've ended up cutting a shorter bolt. I've cut the head off it. I put the bolt actually through the hole and I've plug welded it. Right, so just ignore this. You won't need to do that. Your bolt will be the right length and your bolt head will be out here, okay? You'll just put your bolt through as a normal bolt. But you'll need to cut your 50 by 8 millimeter flat steel that you've purchased. Okay, you'll need to cut a length of that at 65 millimeters in length. Okay, you'll cut two of these, 65 millimeters long. Right, you'll measure halfway, it's a 50 millimeter width, and you'll mark 25 mil. Get a square and draw a line. Then from the top, you will measure down 15 millimeters. Make a mark, put your square on, draw a line. You will punch and drill there. That's where your bolt's going to go in. And you do that for 2 brackets. Okay, guys, yours is going to be slightly different because I've ended up using some 75 by 5 millimeter flat steel because I've run out of my 50 by 8 millimeter. You're still going to have enough to complete these brackets all in 8 mil by 50. So you'll just do what I've done here, but slightly different, okay? Because you're not going to be 75 wide, you're only going to be 50. Now, I wanted to talk about these brackets that I've just made up and recommended that you guys do the same, but in your 50 by 50 by 8. Now, in retrospect, and because of the way that this new bracket is set up on the front of the top frame and the forces that it will deal with, I don't think it's a bad idea actually to make that bracket from the 75 millimeter width by 5. Because in itself, the way that it sits on the plate, it will act as bracing for the plate. Now, the forces on our plate here, okay, the plate's not being pushed this way. It's not like it's being pushed out. It's got to ride up and down, okay, as our motors ride up and down, but it does have to put up with a bit of twisting force when the motors go in opposite directions for roll, for example, okay? Now that will put a bit of stress on the timber when that happens. But this plate, by its very nature, because it's so large in that area, it will actually act as a bracing on the timber. So if you wanted to build your brackets, basically like I have, using the 50mm by 8mm thick flat steel for your bolt location, and then weld that in to your 75x5 plates and just build them like I have, and that wouldn't be a bad thing, guys. These were the brackets off the old rig. They did a great job and they would continue to do a good job like this. So it's really up to you. Now, you just need to keep in mind that if you do use your 50mm wide flat steel as your bracketing, you won't be able to place that flush to the bottom like I have with mine, because your bolt hole locations will be too close to the edge of the timber here. Okay, so you'll have to locate them 35mm from the edge. Okay, so if you are using your 50x50, please locate your brackets 35mm up from the bottom. You'll run them still on the edge like this. You'll still run them 5mm in from the edge, but run the whole bracket like this one. Okay, this one runs up to the center, and that's basically 35mm from the bottom here. Okay, if you're running your 50x8, or if you choose to do what I've done and use the 75x5, you can just run those bolts like I have in the center, and you'll have that nice 35mm clearance from the bottom. Anyway, that's a bit of food for thought, but the principle is exactly the same. So you're going to cut two lengths of your 50x8mm flat steel at 110mm in length of 110, right? In your case, you're going to find the very center of your 50, which will be 25mm. You'll make a mark, you'll draw a line to find the center of your 25. Okay, then you'll measure in 30mm and make a mark, put your square on and draw a line. And from the other side, measure in 30mm, put a mark, put your square on, draw a line. Where those lines intersect, you will punch at those intersecting lines on each 110mm length piece, and we are going to drill these. Let me show you how we build the bottom part of our top frame front motor connecting rod bracket. Look, I hope you're not too confused by this. I've run out of 50mm by 8mm flat steel. So my bottom bracket section here is going to be with some of the 75x5mm steel. Principle's going to be exactly the same. It's just that you're going to use your 50mm by 8mm thick. Where our bracket is going to attach on the top, and you'll see here, same deal where we've marked our bracket in the center. We line it up to be in the center. You will line it up to be in the center. Right, now your bottom bracket is not going to be 75 wide. It'll be 50 wide like this, but you'll bevel out this edge here. You'll bevel out the top part of your bracket here, and you'll bevel out the front part of your bracket here. So I'll bevel both sides here, and then just bevel along the length of your 50mm, ready to weld these together. Okay guys, we've got our 110mm length bottom part of our bracket in our vise. We've got our welding clamp on it. We've got our fan running. Okay, we've beveled our tie rod connecting part of our bracket. We're going to line that center mark up. Right now, where I've beveled this off on my bottom piece, I've just remarked, because obviously when you grind that, you're going to lose your marks. We're going to bring those two marks exactly together so it's in the center. Rightio, and then what we're going to do is we're going to hold our bolt and we're going to tack in the corners. Just reinforcing again, guys, the need for this to be at 90 degrees, nice and straight. You're not going to have a bolt welded into your piece, so you'll be able to get your welding magnet, your angle finding welding magnet, set it up at 90, so get this nice and straight. Now this comes all the way flush to the end of the bottom bracket, okay? So put your welding magnet on, get it at 90, put a tack in both corners at the front, a tack in both corners at the back, then run your welding bead into the gaps you've created with your bevels, front and back. I want to talk about these little conical spaces I talked about that we're going to make out of our 10mm pipe, okay? So what I recommend, these are 10mm in width, and you can see there I've chamfered the end off. It's going to be much easier for you to chamfer the end if you do it with your complete piece of pipe this is 1 metre, before you cut it. So shape this. I do this like I showed you how to use the angle grinder, with the angle grinder upside down on the table, and then you can hold this up and run this around and around, spin it on the grinding disc on your angle grinder, right, until you get a nice little chafer like that. 10 millimeters wide, okay? Happy days. You can put your conical spacer on with the chafered side facing inways. Then your connecting rod, okay, so that now gives our connecting rod extra room to move, all right? Then you'll take your Nylex nut, and instead of putting it on that way, you'll put it on this way, so then the machine top can act as a conical spacer at the other end. You'll need to do this up with a socket holding your bolt, because it's a Nylex nut. It'll grip, and you'll have to actually put it on with a socket or with 2 shifting spanners. And you'll do both sides exactly the same, and then your connecting rods are on. We'll talk about the lengths that these need to be very shortly. Okay guys, we need to talk about how we line up our connecting rod to motor brackets onto our hardwood timber. So you need to line these up, okay, so then they are 5 millimeters in from the edge. Both sides, so that side needs to be 5 millimeters in, this side is 5 millimeters in, and you line them up with the bottom of our timber, right? So they line up flush along the bottom edge of your timber, 5 millimeters in from the edges, both sides. Then you'll need to get your Sharpie, okay, and you need to come through and you'll need to mark through your holes onto your timber, okay, mark through your holes onto your timber, so then we can drill our timber for our M8 bolts that will hold these brackets in place. This is the scenario you guys should be looking at, okay? Your brackets 5 millimeters in from each edge, okay, and flush with the bottom of the 560 mil piece of hardwood, right? That's how they need to locate. So there's a couple of things you guys are going to need to do now, all right, to get this all set up. So I've got this now screwed to my top frame, and I've got my push rod brackets now secured in place, ready to go. So first thing we need to do is we need to make sure that our motor levers are exactly level, okay, this way. It's because we need to set up our heights on our rods now, okay? So you'll use a combination of your spirit level on the top of your frame, okay, and then we'll manipulate our rods, our M12 thread here with our tie rods. So I can tell you now, you need to cut 2 lengths of 155 millimeters in length M12 rod, 1 for each side, okay? And then you'll have to play around with the way that these are adjusted on your motor lever end and up the top here where they go into our brackets. You'll need to wind these out to get them as even as you can inside your tie rod. Now you want to make sure you've got a good amount of thread inside, which there will be if you cut that length. And then you just need to wind them on until you've got them onto your brackets. Stands are gone, guys, and my top frame is now completely connected via my tie rods and the rod, our M12 rod, to our motor shafts. So these will happily support this frame, no problem, with no weight on it. So this is just a bit fiddly, guys. It just takes a little while for you to get your lengths right. Get a spirit level, put it on your frame, and use your spirit level as a guide, okay, to get the frame level. So mine's still got a little bit of tweaking, but it's very close. All right, so run a spirit level while you're doing this, all right? And make sure that when you wind your rod in to your tie rods, that there's a good amount of rod in. So that measurement I gave you will allow plenty of rod, plenty of M12 threaded rod here inside your tie rods. And you've got to remember, before you run your tie rods on, remember to put your 2 M12 locking nuts on each rod first. Because then once you've got the heights adjusted and right, you'll run these back down and lock these rods so they can't unturn themselves. Now, the other thing to remember too is make sure that you run your Nylex nuts right on backwards, so then they act as a conical spacer. Do it at the bottom and the top, both of your rods on both sides. So it'll just take a little bit of time. Now, obviously, I should have mentioned this, you'll need to get your battery on your motors because you need to make sure that your levers are level, right? So you'll have to manipulate your motor levers with your battery until they're level, because they need to be level to get this all set up. Now, you would have noticed straight away, well, I assume you would, I'd want to hope so, that I've reversed my motors now. And I've turned my motors and they're facing this way. They're no longer facing this way. I did a bit of a calculation on the weights of the new peripherals I'm adding to the frame, right? The Fanatec direct drive wheel, the Fanatec V3 pedals, the bigger pedal cage, the bigger steering wheel apparatus. It's all adding weight to my top frame. So to keep the balance and to keep things light on the motors, I've moved the pivoting point right to the front of the frame. I've just done a continuity test with my multimeter and everything is isolated from the frame. So the way this is set up on the hardwood, it's isolated from the frame and we're right to go. So this is how you need to set it up now. This was no drama. Those brackets just turn around. The bolt hole patterns all still lined up. So you shouldn't have any dramas with that. You're going to turn these brackets around now so they're facing this way, not back this way. All right, so that's the main change. Okay, guys, well, good luck with setting that all up. It's a bit fiddly. It'll take you a bit of time. Get someone to help you with the frame if you need it, or get some stands that you can have your frame resting on while you're getting all of this stuff lined up. And good luck, guys. Have fun. Have fun doing it.